Hello everyone. This session is about layer view of FCC and HCP. So first let us discuss layer view of FCC. So here FCC, the full form is face centered cubic lattice. Face centered cubic lattice, which is also known as CCP, cubic close packing, because in all close packed structures FCC has maximum efficiency. That efficiency is 74 percentage. So 74 percentage of space is occupied and remaining 26 percentage is voids. And now let us discuss the layer view, how the particles are present in different layers in FCC. After that HCP, let us try to discuss. So if you see the particles of first layer, so basically two examples, one is copper and silver. These two metals crystallize in a FCC structure. So during this discussion you can assume these atoms may be either copper metals or silver metals. So first let us take the particles of a first layer. So these are all the particles of a first layer, and if you carefully observe, in first layer the particles are arranged in two-dimensional HCP. Two-dimensional HCP like this. You can see the particles of first layer are arranged in two-dimensional HCP, and due to this type of arrangement two types of voids are generated. You can see between the particles there is an empty space, and that empty space is in triangle shape. Therefore these voids are triangular voids, and of course these triangular voids are two-dimensional voids. So the particles and the voids are in the same plane. Therefore this triangular void is a two-dimensional void. You can see triangular voids yellow in color, triangular voids blue in color. The difference is here vertex is up and here vertex is down. So the arrangement of particles in first layer of FCC is two-dimensional HCP. Two types of voids are generated. Both are triangular voids. The difference is vertex up, another one is vertex down. So this is the arrangement of particles in first layer. And if you see the particles of second layer, so of course you are assuming this one as either copper solid or silver solid. In fact these are copper atoms, these are also copper atoms. For the sake of better understanding we are taking in different color. So here these are the particles of a first layer, these are the particles of second layer, and if you carefully observe the particles of second layer cover one type of triangular voids. Here we have two types of triangular voids in first layer. One is shown in yellow color, another one is shown in blue color. So the particles of second layer cover either yellow voids or blue voids. One type of triangular voids are covered, and in this picture you can see the particles of second layer are covering triangular voids which are yellow in color. So the particles of a second layer cover triangular, one type of triangular voids produced in first layer. And after placing the particles of a second layer, you can see this is the unoccupied triangular void. After placing the particles of a second layer, that unoccupied triangular void, now it is octahedral void. You can see this particle, this void is surrounded by six particles. The six particles are 1, 2, 3, 4, 5 and 6. So three particles of a first layer, three particles of a second layer. Totally this void is surrounded by six particles, and this void is a octahedral void. and a new void is generated. That new void can be seen, that is in red in color. So here this is tetrahedral void and this is octahedral void. After placing the particles of second layer, the second layer particles are covering one type of triangular voids in first layer. Whatever the unoccupied void you had in uncovered void you had in first layer, that is becoming octahedral void, and a new void is generated. That new void is a tetrahedral void, and these are the tetrahedral and octahedral voids produced after placing the particles of a second layer. Now what about the particles of third layer? The particles of third layer, these are the particles of third layer, particles of first layer, particles of second layer, and particles of third layer. And these particles of third layer are covering octahedral voids. So here these are covering octahedral voids, so not tetrahedral voids, octahedral voids. So these are the particles, and the particles of a third layer cover octahedral voids produced by first and second layer particles. And finally the fourth layer of FCC, if you see, the particles of fourth layer are exactly above the particles of first layer. So here these are the particles of first layer, these are the particles of second layer, these are the particles of third layer, and this is again the particles of fourth layer. Fourth layer particles are lying exactly above the particles of a first layer, and this is the arrangement of particles in different layers. So the first layer is two-dimensional HCP. Two types of voids are generated, triangular voids. Both are triangular voids, vertex is up, vertex is down. Particles of second layer are covering one type of triangular voids. After placing the particles of a second layer, two types of voids are produced. Unoccupied triangular void is becoming octahedral void, and a new void is generated, that is tetrahedral void. The particles of a third layer cover all octahedral voids. Tetrahedral voids are not covered, octahedral voids are covered, and the particles of a fourth layer are lying exactly above the particles of first layer. And if you see the layers in one unit cell, for example, this is a FCC unit cell, and the particles are present at face centers and corners. You can see in this all face center particles and face center positions and corner positions are occupied. You can see here this is a corner particle, this is a face center particle. All face centers and corners are covered. And if you see one unit cell of FCC has four layers, and here this is the corner particle belonging to first layer. Now you can see this is another corner particle of the same face, corner, face center, corner, face center, corner, face center, and corner. And all these particles, you can see this is in contact with this is in contact with this, like this, next this one, followed by this one, finally this one. So these six particles belong to second layer of FCC. So this particle belongs to first layer, this these six particles belong to second layer, and this is another corner. So here corner, face center, corner, face center, corner, face center, and corner. So these six particles belong to third layer, and this last particle, this belongs to fourth layer. So here 1 plus 6 plus 6 plus 1. So totally there are 14 particles in one unit cell of FCC. These 14 particles are actually coming from four layers. One particle is coming from first layer, 6 particles are coming from second layer, 6 particles are coming from third layer, and 1 particle is coming from fourth layer. So let us say this is layer A, layer B, layer C, and this is layer A, because here the particles of fourth layer are lying exactly below the particles of first layer. That means fourth layer is the repetition of first layer. Hence, this arrangement is A, B, C, A arrangement. And one important point you have to notice, when unit cell is lying on its one of the faces, the layers are diagonal. Layers are not horizontal, the layers are diagonal. You can see these are the layers. So first layer, second layer, third layer, and fourth layer. So one unit cell of FCC has particles of 4 layers, and of course, since it is a closed packed structure, you can see this is the particle of first layer, and this is a layer, 6 particles of a second layer, 6 particles of a third layer, and 1 particle of a fourth layer. So the layer view of a FCC unit cell, the layers are, you can see, diagonal layers. Layers are diagonal. So totally here 1 plus 6 plus 6 plus 1, we have 14 particles. These 14 particles belong to 4 layers. And if unit cell is lying or standing on one of its body diagonal, for example, if you turn unit cell like this, you are going to get arrangement like this. This is the arrangement you are going to get. In this, you can see unit cell is standing on its body diagonal. So here, when unit cell is standing on one of its faces, you can see the layers are diagonal. If you turn this unit cell like this, and if it is allowed to stand on one of its body diagonal, the arrangement will be like this. This is the arrangement. Now the unit cell is standing on one of its body diagonal. First layer particle, second layer particles, third layer particles, and fourth layer particles. And this is layer particle of layer 1. This is particle of layer 4. Now unit cell is standing on one of its body diagonal. Then layers are horizontal, and the distance between these two particles, layer 1 and layer 4, that is root 3a, root 3 times of a. So here in this picture you can see unit cell is standing on one of its body diagonal, and here this is the top view of unit cell which is standing on its body diagonal. If you see, if this is the position of observer, if you are seeing the unit cell from this direction, you will be finding unit cell image like this. That means you can see only the particles of first layer, second layer, third layer, fourth layer is not visible. But in this picture, this is the side view. Unit cell is standing on one of its body diagonal, and this is the side view, and this is the top view, and these are the layers. You can see here unit cell is standing on its body diagonal. Now the layers are horizontal, and the distance between these two layers, first layer and fourth layer, that is root 3a. And this is about a layer view of FCC. And if you see layers of HCP, simply the first two layers arrangement is exactly same. FCC and HCP, the arrangement of particles in first two layers, that arrangement is the same. You can see the first layer is two-dimensional HCP, two types of voids are generated, Both are triangular voids. Vertex is up, vertex is down. Particles of second layer are covering one type of triangular void. You will be getting two types of voids. This is newly generated void, tetrahedral void. The unoccupied triangular void is becoming octahedral void. And the main difference in case of FCC, the particles of a third layer cover octahedral voids instead of octahedral voids. If tetrahedral voids are covered, tetrahedral voids, if tetrahedral voids are covered, you are going to get a hexagonal close packing. So the particles of a third layer, the particles of a third layer are covering tetrahedral voids. So here these are the tetrahedral voids, and the tetrahedral voids are covered. As a result, the particles of first layer and particles of third layer, if you see, the particles of third layer are exactly above the particles of first layer, and this arrangement is AB, AB, AB arrangement. AB, AB, AB arrangement. And if you see the one unit cell of HCP, so here this is the first layer, this is the second layer, and this is the third layer. There are only particles of three layers, whereas in FCC there are particles of four layers. So these are actually covering triangular voids of first layer. After placing second layer, you are going to get two types of voids, tetrahedral and octahedral, and the particles of third layer cover tetrahedral voids. And you can see the comparison. This is a HCP unit cell and this is FCC unit cell, and this is the layer view of FCC and HCP. Thank you very much.